All right, what I want to discuss now is internal rate of returns, and yeah, so after this video, I'll discuss net present value and the related concept of the associated, rather, hurdle rate to a net present value. And then we'll discuss some other ways to measure the return of an investment, like modified internal rate of return, and other similar measurements. And then finally, I'd like to do a video on yield curves, particularly because they're just so germane to the current situation of the Fed setting interest rates incredibly low to make stocks incredibly, some would say artificially attractive, which to some degree is keeping the economy afloat. But anyway, so let's discuss internal rate of return. And in some sense, we've done internal rate of returns already. We've done the yield rates of investment situations, but we're going to redo it from a more, I guess, more practical, not maybe practical, but a slightly different perspective. That's the perspective of a cash flow. So for example, let's say we have an annuity, and we know that the price of an annuity P is just present value of all payments at some interest rate J. And J is the effective per period interest rate. So for example, we have a 20-year loan, payments $1887.86 at the end of each year, 7% effective annual interest. We know the price of the loan, or the loan amount, same thing, is going to be $1887.86, a 20.07, which is basically $20,000, right? So a slightly different perspective than we've been taking is if we're taking the perspective of a lender, then we have a cash flow associated to this loan where the lender has to dole out $20,000, so that's their investment, that's their cash out, and the returns, the revenue this lender gets for this initial outlay of $20,000 is 20 payments of $1887.86 at the end of each year. Okay. And one way of thinking of this is simply at 7%, the cash out, my initial investment of $20,000 equals the cash in, the $1887.86 payments I get at the end of each year, time value. Right? And in that sense, that's all there is to internal rate of returns. If that made sense, then you understand internal rate of returns. It's literally just an interest rate at which cash in equals cash out, right? And what do I mean by that? Well, it's exactly what I just discussed. To get some revenue, to get some cash in, we have to incur expenses, we have to make investments, cash out, and we have to incur equal expenses, time valued, at some interest rate, J, which we call the internal rate of return. Rather, well, I'll leave it at that for now. Notice that I'm not really actually writing the, and I'm writing and. I'll get to that a little bit. And I'm writing a and not the, but anyway. So I probably should say a instead of the, but it's all right. I'll explain that, what I mean by that in a moment. But one way of thinking of it, just very practically, is that it's an interest rate for your investment. It's your investment interest rate. Okay. And that's a very practical way to think about internal rate of return. It's just an investment's interest rate. All right. By definition, it's an interest rate J, or a rate J, where the present value or the accumulated value of a cash flow is 0. Right? If the present value is 0, then so is the accumulated value. And if you remember from way back, maybe like the second or third week in class when we did equations of value. We did equations of value at really any reference point whatsoever. And if you take the time-valued sum of this cash flow at any reference point, or with respect to any reference date, you'll also get 0. If you ever do IRR problems, practically speaking, you're going to take the present value or the accumulated value, usually the accumulated value. And here's the associated timeline. Notice that in general, you know, the investments and the cash in, the cash in, the revenue that we get could really occur at any times whatsoever, not just 0, 1, 2, et cetera, et cetera. Usually we always start at, we always have some starting point. So we always start at 0, but it doesn't have to be equally spaced time periods. And actually, Excel can easily do internal rate of return calculations with irregularly spaced cash flows. I don't think the BA2 Plus can, but they can do, the BA2 Plus can do net present value calculations for cash flows that are not regularly spaced. And we'll do a problem like that actually in the next video. All right. So some important notes. Basically, we went over this already. The internal rate of return of an annuity is nothing more than its interest rate. Okay. Well, a bond is an annuity. And how do we price a bond? Well, we price it as an annuity using the interest rate as the yield rate, or using the yield rate as the annuity's interest rate. Okay. So because the yield rate is the bond's interest rate as an annuity, and because an IRR is the annuity's interest rate, the yield rate is literally the bond's internal rate of return. Right? Third, and this is a little bizarre, it just happens, internal rate of returns are not necessarily unique. As a matter of practicality, what does this mean? Well, it means this is true for, this can be true for multiple J's, but more practically, you could just have multiple interest rates where time value cash in equals cash out. Right. And I should say, when I say cash in equals cash out time valued, that's an equation of value at some reference date, and it doesn't matter what reference date at all. You're always going to, just like we had with equations of value, it's always going to be true regardless of when we're dating things. Anyway. Okay, and I'll do an example of this to illustrate that it's not that bizarre, and because you don't necessarily get unique internal rate of returns, that's a slight drawback of an internal rate of return. And last, not surprisingly, higher internal rate of returns are generally preferred. When you have an investment, you want as high of an interest rate on your investment as possible. If you're a mortgage lender, you would like to charge as high of an interest rate as you can, because as a lender, the higher the interest rate, the larger the payments are. Right? If I had 10% interest, I'm guessing the payments might be $2,500. I don't know, but they're certainly going to be quite a bit larger than 1887-86. Right? Of course, taking the flip side, if you are if you're trying to buy a house, you of course want as small of a loan interest rate or mortgage interest rate as you can get. But we're taking the investors, the lenders' perspective, because this is a course on preparing you to become an actuary. So, it makes more sense to take an investor's perspective or a lender's perspective. All right. Okay, so let's do an example, and let's find two internal rate of returns for this cash flow. And you'll notice this is not a very crazy looking cash flow. I mean, we get at the beginning $1. At the end of, let's say, years, doesn't matter. At the end of 2 years, we get $1.32. And to do that, we have to pay $2.30 at the end of the first year. Without time valuing anything, that's a net profit of 2 cents. But anyway. Okay, and I'm just picking small numbers to make the by hand calculations a little easier. Of course, just like with interest rates for loans, computing them, you really in general can't do that by hand, as we'll see in a second why. Okay, so here is my cash flow. Let's take the future value of the cash flow. You could also take the present value. It's just a little more work. All right, so we're going to, well, this $1 is going to accumulate 2 years of interest at some effective annual interest rate J, essentially. So like I said, you really should think of a internal rate of return as a investment interest rate. All right? So that's not very subtle. That becomes 1 plus J squared times 1. I'm not going to bother to write that. The minus 2.3 accrues 1 year of interest, so it's minus 2.31 plus J. And the 1.32 doesn't accrue any interest. And remember, we have to have negative accruing interest because that's money I could have invested at this interest rate. Okay, so let 1 plus J be x. So we get x squared minus 2.3x plus 1.32 equals 0. We do the quadratic formula. Remember, it's negative b. b is minus 2.3, so negative makes it positive. So it's 2.3 plus or minus b squared minus 4ac. A is 1, c is 1.32. So inside the square root, you will get 0.01. Take the square root of that, it's 0.1. So it'll be 2.3 plus or minus 0.1. 2.3 plus 0.1 is 2.4 over 2 is 1.2. 2.3 minus 0.1 is 2.2 over 2 is 1.1. So we get two answers for x, 1.1 and 1.2. Remember, x is 1 plus j. So j is 0.1 and 0.2, which corresponds to yield rates of 10% and 20%. So it's generally commonplace just to take the lesser of the two. That's what's more realistic. And that's actually what the BA2 Plus does. All right, so let's see that. So first of all, I want to make clear that in the most simplest annuity situation, which is a cash flow where you have the initial amount is negative, that's your initial outlay, your initial investment, your initial what you're loaning out, and then the rest being positive, those are the loan payments you're receiving. If you're in that situation, then something is, well, what's true is the internal rate of return is unique, and we've actually been implicitly doing this. I mean, we've been implicitly finding loan interest rates, assuming they are unique. It'd be kind of bizarre if it wasn't for basic loans. But yeah, I think this follows from Descartes' rule of signs. If you look into a accounting book, you'll often actually, they'll have at least the one accounting book I have has, or maybe it's, sorry, it's a corporate finance book. They have like a page on, I think, how to show this. But anyway. Okay, so right, let's use the BA2 Plus to get the smaller internal rate of return. And in general, let me explain how you use calculator to get internal rate of returns. Okay. So this is a mouthful, and I'm just dumping this on screen really and on the PowerPoint for your reference in case you just want a quick view. If you forget how to do it, you don't have to go back to the videos. So let's do exactly what I'm doing here. All right, that's good. So we're going to go to cash flow. That's CF right here. And I've already done some calculations. So let's just clear all the stuff. And that's why we go to the second clear work. Clear work is the yellow here. So, okay. So what we do is we hit 1. So this is my initial cash flow amount. And it's 1 here, so we hit 1, enter. We go down. This is when t equals 1. So that's minus $2.30. So 2.3 minus, enter. For now, we're just going to ignore this F01. We'll do an example of it in a second. It's actually, it means frequency. But so we're just going to hit it a second time. And this is t equals 2. We enter 1.32. Enter. And not very subtly, we're going to hit IRR. And then we hit CPT for compute. And your calculator actually might take a second, full second, second and a half to do this computation. But we get exactly what we got before, the smaller of these two internal rate of returns, 10% and 20%. So, and remember, just like with doing loan interest rates with the calculator, by that I mean with constant payments, the calculator is going to spit out a percentage. All right. Okay, so let's look at the frequency button and how to use that. And in particular, let's check something from the latest exam, the last problem. A $70,000 loan requires 30 payments at the end of each year for 30 years. The first 10 are $3,000, the next 10 are $4,000. And you were in the exam, you found that the last 10 are 95, 77, 52. I told you that the per effective yearly interest rate is 5%. Let's check that. Sorry, that I meant to keep this here, but it doesn't matter. Anyway, find the interest rate for the loan. And interestingly, you really can't do this using the time value of money keys. We have to do this treating this loan as a cash flow and finding the internal rate of return for that cash flow, which is a loan interest rate. All right. So how do we do that? And again, it's a mouthful. Well, first of all, here's the cash flow associated to the problem. And we're going to enter all of this. Again, this is just for your reference. So let's just slowly go over it. Yeah, so first of all, just like before, we're going to go, we're going to go to cash flow and then clear work. So let me move this over here. Should be good. Okay, so we hit 70,000. Sorry, I don't think you can see that. Move this over a bit. Well, anyway, it's there, so you can open up the PowerPoint. So we're going to hit 70,000 negative, enter. That's my initial investment. So then we go down. Then we hit 3,000, enter. That's my next one. But that's repeated 10 times, so the frequency is 10. And now we go to the next one, which is 4,000 repeated again 10 times. And last but not least, 9577.52. And that's repeated again 10 times. Okay, so now we're done. We've taken care of all 30 years. Internal rate of return compute. And, well, due to minute rounding, we don't exactly get 5%. We basically get 5%. There's 6 nines there, so it's 5%. Okay, and again, what I did was just everything is here. Okay, so last, let's very quickly talk about negative internal rate of returns. Okay, just like with investments, having a negative investment rate means you're losing money. So for example, let's find the internal rate of return for the following cash flow. So you're definitely losing money. You invest 600 and you only get back $560. So you've lost $40. All right, so let's find the internal rate of return. Again, cash flow, clear work. So we know this is easy. 600, go down. 60, enter, go down. Go down again. I would just enter 200 twice. It literally saves me a second to enter the frequency twice. And it's, if you can avoid it, there's no point in doing it. So, yeah, I mean, it doesn't save you. You know, the whole point of the frequency button is to save you time. Okay, so we entered all this, and I believe it's going to be minus 2.6%. Okay, so I must have done something wrong. So let's try that one more time. Cash flow, clear work. 600 negative, enter. 60, enter. 200, enter. I'm going to do, again, 200 for the third instead of setting the second frequency to be 2. And then, last but not least, 100, enter, internal rate of return. Yeah, we get minus 2.6. I'm not really sure what I did to make my calculator unhappy, but if you're just focusing on something else, like I'm focusing on this video, and you get an error or you get a garbage answer, just re-enter enter the calculator. Okay, so one thing I want to emphasize with negative internal rate of returns as a matter of practicality, sometimes you just have to deal with negative internal rate of returns. For example, a very practical example, let's say you're a contractor and you want to build a residential home, or sorry, you want to build a residential apartment complex. All right. The municipality you want to build and says, great, knock yourself out, but 10% of those apartments have to be affordable housing apartments. Now let's say you want to look at the cash flow associated to those affordable housing apartments in the sense that you make expenses building them and you're getting in monthly rent, and you have expenses renovating it, fixing things. So it just might be that just looking at those houses by themselves, so those apartments by themselves, there's no way you're going to make money, but in the overall grand scheme of things, you will make money. So if you want to just look at these affordable homes, these affordable apartments as a cash flow by themselves, you might not be able to avoid negative internal rate of returns, but you still might want to get the one that's closest to 0, the one where you're losing time valued the least amount of money. So negative IRRs, sometimes they just happen, and there's nothing. You still want to maximize your internal rate of return so that you minimize your losses, time valued. Okay, so yeah, I'll discuss net present value in the next video. And yeah, all right. Until then, so long, take care, stay safe, and the end is near, thankfully.